previous session, we have seen how to construct a 3-bit up-down counter. In this session, we'll be constructing a 4:1 multiplexer in Verilog. And for this, we'll be using the language template provided in ISC Design Suite. The block diagram is as shown. So this is the language template. So we can browse through the Verilog and then synthesis construct and then the multiplexer. So this is the main body of the code. Similarly, for counters, we can have other templates. So we'll be copying the main body. Having done that, so let's create a new project as project 8 multiplexer. Then we'll add a new source as Verilog module. So according to the block diagram what we started with, so let's assign the terminals. Here S0 and S1 are the select lines which are single bit input, and A is the 4-bit input. So we'll be defining it as 3 down to 0, and output is a single bit number, single bit variable. Now we'll be pasting the block which we have copied from the language template, and since we'll be using Q in the always block, we need to define it as a register, and then the sensitivity parameters will be A, and then the select lines. So inside the case block, we have S1 and S0 with S0 as the LSB. So here we are using blocking assignment so that it results into combinational logic. So the module is ready. So let's quickly synthesize and check the top level schematic. So the block, it looks more or less similar to the part what we started with. So let's quickly test the module with test fixtures. So the input combinations can be supplied in this test fixture so as to test the module. In order to bring out or test the module in very simple sense, what we'll do is, note A is a 4-bit number, 4-bit variable. A is a 4-bit variable. And we'll copy the lines. For the ease of studying the output analysis, for the ease of output analysis will define the inputs appropriately and will set the select line lines appropriately. Note S0 is the LSB while S1 is the MSB of the select lines. So let's switch to the simulation mode and then simulate the behavior. So the output is obtained in the iSIM program as shown. So depending upon the select line, the 4-bit inputs what is supplied with the variable A, it gets transferred to the output. So this is what we talk about 4:1 multiplexing. So the functionality is verified here.